Hello and welcome to the fourth video in our linear function series. The topic for today will be slope point form for a linear function. Let's look at the basics of slope point form. Any equation of a line that passes through a point, which I'm going to call x1 and y1, and has a slope of m, is equal to this. This is the slope point form right here, everybody. Y minus y1 equals m bracket x minus x1. So we just take the coordinates of that point, we put them in those spots that I've highlighted there, and we throw the slope in that slope position there. Some examples of what this could look like. It could be y minus 2 equals 3 bracket x plus 1, or y plus 1 equals negative half bracket x minus 4. So that's how it's going to look. All right, so let's practice finding the slope and a point from this form. So the first thing I'm going to do is, until we get it down a little bit better, is I'm going to write this in slope point form. But what I mean by that is like that perfect slope point form. So remember, this would be y1 over here. This is our x1. And we can see the slope already. So the slope's easy to find. I can write that down. So m equals 1/2. That's easy. It's finding the point that doesn't take any work, but I just want to make sure I explain it to you guys properly. So we want to say x minus 3, or sorry, y minus 3. So then this would be just y minus 3. So we know the y value is a positive 3. Over here, though, we want the x to read x plus 2. Now, in the default slope point form, it's x minus something always. So in order for it to read x plus 2, this x value must be a negative 2. Because then together, we have the sign change, and that'll look like x plus 2. So our x coordinate should actually be negative 2. So the point would be negative 2 and positive 3. So the math behind it is what I've shown you. If you want like a little memory trick, the y is always equal to, well, I guess both values are opposite what they look like. It looks like that might be, you might interpret this as negative, well, it's actually positive 3 when it's a point, and this looks like positive 2, well, it's actually negative 2 in the point. So that's kind of your memory trick, but the math is simply because of those brackets like I explained in the initial part there. Let's look at it again. So I'll write it in this slope point form, like the perfect slope point form. And again, this is my y1, this is my x1. So it reads y plus 4, so that means this must be a negative 4, that y value. That would create or cause a sign change and would read y plus 4. Over here, it's x plus 1, so that means this must be a negative 1, because again, together, they'd make a positive. So then my values, again, the slope is always easy, so that's negative 3 over 4. The point that this line runs through would be negative 1, negative 4. Awesome. Second example, let's write an equation for each line in slope point form. So in order to write something in slope point form, you need to know the slope, and then you need to know a point. So in this set of examples, or in these two at least, I'm given the slope and a point. So this should be pretty easy. Again, I'm just going to write y minus y1 equals m bracket x minus x1. By the way, where that comes from is your 2-point slope formula, everybody. That if I have this, and I think of cross multiplying, I get then y2 minus y1 equals m bracket x2 minus x1. And seeing we're only dealing with one point, we just ignore the second coordinates, and that's right there. That's your slope point formula, everybody. Back to this question, though. So I know my slope is 3, so I can plug that in. And I also know this is x1, this is y1. So I get y minus, I'm going to use the brackets, negative 3 equals 3, x minus my brackets, and my x value is 2. So now I'll go ahead and do my sign changes. So that would be y plus 3 equals 3x minus 2. Now, seeing I'm showing you how to do it, that's why I like using my expanded or my written out full slope point form version. But if you just want to jump right into it because you understand the sign changes, by all means do that. You don't have to do exactly what I'm doing. So once again, I'll write out my slope point form with my open brackets. And then this is x1, this is y1. So y1, 7 goes there. This is negative 3. And when I use these empty brackets, it just, for me, I think it really highlights the sign changes for students. So I'd get y minus 7 Now my slope I haven't plugged in yet, so that's negative 2 over 5. X, and then here's my sign change, that's a plus, so x plus 3. All right, so that's how you put something into slope point form. And remember, you need to know the slope of that line and a point. So now in this question here, they don't give us the slope, but they just give us 2 points. So if we think about it, could we find the slope with these 2 points? Yep. And then we still need a point for the x1, y1, and you can see here I have 2 points. So really, I have more than enough information. I can find the slope with these 2 points, and then I have a choice of points to sub in to complete my equation. So slope point form for the same line can look a bunch of different ways. So that's maybe one of the downsides of slope point form, but there's lots of upsides too. Once we're done, we'll convert it to slope-intercept form just for that practice as well. So the first thing I'm going to do is I need to find the slope. So to find the slope, we think rise or run always maybe, but rise or run, that is what we use when we have a picture. We don't have a picture, we just have this information, so 2.4 is perfect. So that's y1, or x1, y1, x2, y2. Again, my open brackets, just to really make the sign changes easier. Y2 is 4, y1 is 3, x2 is 5, x1 is 7, 4 minus 3 is 1, 5 minus 7 is negative 2, so negative 1/2. So I've got my slope. Now I just have to actually pick a point. And it doesn't matter which point. I'll just call this point A, 7 and 3. And if I chose point A, then my equation would look like y minus, and I'm just going to keep going through using these open brackets. X minus, so this is x1, this is y1, this is a 3 now, then so x1 is 7, do my sign changes, y minus 3 equals negative 1/2 x plus 7. That is what it would look like if I chose point A, and that would be right. But you could have also chosen point B, and you'll get a different looking equation, but it will be right as well. So slope point form can look a bunch of different ways. As long as you have the correct slope, and then you choose a point that the line passes through, then you're good. So again, just using my open brackets, 4 goes here, 5 goes here, so y minus 4 equals negative 1/2 x minus 5. Both of these would be right. Okay. The third thing we're going to do is we're going to convert to slope-intercept. Now remember, slope-intercept is y equals mx plus b. The thing I want to really highlight is that we have the y on the left side by itself. So that's what we're going to attempt to do here. I'll take what I have. So I'm going to work with the point A version. Both, it wouldn't matter which one I work with. Okay. Now, I have a fraction, right? What I want to do here is if I multiply by 2, the denominator of that fraction, that'll get rid of the fraction. So remember, you can do whatever you want to an equation as long as you do it to both sides. So I'm going to multiply this whole thing by 2. Now, when you do that, what you're doing is you're multiplying everything outside a bracket already by 2. So I would get 2y minus 6 equals 1/2 times 2 ends up to be negative 1. Now the items that are already in a bracket, the x plus 7, they remain unchanged. So now I've just adjusted the look of this, but seeing I multiplied everything by the same value, that's okay. I have not changed the look. I haven't changed the line, just the way the line maybe looks or is presented. And then now I want to get rid of my brackets by just multiplying. So 2y minus 6 equals negative x minus 7. And this is where I'm going to start now clearing everything out because I want to get this y by itself on that side. So I'll add 6. Oops, let's switch back to blue. Add 6, add 6. 2y equals negative x minus 1. And then I'm going to divide by 2. I want to divide everything on that right side by 2 as well. So y equals, you could write it as x over 2, but negative x over 2 is the same as negative 1/2 x, and then minus 1/2. And that is the same line, but now it's presented in slope-intercept form. And if I could do the exact same thing with this, you would get the exact same answer. So you would get the same version of the slope-intercept form. So you can have different slope point forms, but they would all convert to the same slope-intercept form. So let's do that one more time. So I want my slope. And after a while, you might feel like you don't need the open bracket, so -2 subtract a -7. That was y2. All over subtract 3. That was x2. X1. That's a plus. So 5 over -9. -5 over 9. All right, got my slope. Now I choose a point. Again, it does not matter which point. I usually choose the first point just because I'm kind of lazy. It doesn't really matter which point I choose. Once I have my point, then I can actually write this in slope point form. So I guess I kind of skipped writing that step out. We definitely wrote the slope point form out, but I didn't make it its own step. So here's slope point. So y minus my brackets, my slope is -5 over 9, x minus my open bracket. So y is here, my x goes here. Again, this is x1, y1. So after my sign changes, I get y plus 7 equals -5 over 9, x minus 3. Okay, and the fourth step, which is an additional step, it's not like you have to do this every time, but we're going to convert it to slope-intercept form. So again, this is an extra step. I'll highlight that. You don't have to do this every time. Okay, this is just something I'm throwing into a question. Whenever your slope's a fraction, you have to do that first fraction step. But the fraction, if you don't have a fraction, then converting this is really quick. Anyway, so I'll start out by just writing my slope point form down. And again, because I have a fraction right here for my slope, that means I want to get rid of my fraction. So I'm going to create an equivalent expression. So it's going to mean the same thing, but it's going to look differently. And you always simply multiply by whatever your denominator is. So I'm going to multiply everything by 9. So, and again, I multiply everything by 9 that is not already in brackets. All right, so I would get 9 times y is 9y. 7 times 9 is 63 equals, maybe I'll do this in red over here just in case you kind of forget how to multiply fractions. So you get -5 over 9 times 9 over 1. Now, depending on how you work with fractions, I like reducing fractions first. So I'd see that 9 and 9 have something in common. I divide that out. So it's a 9 in common. So 9 divided by 9 is 1. 9 divided by 9 is 1. So now I'd get -5 times 1 because you multiply straight across everybody. So it'd be -5 times -1. That's -5. And then you would get 1 times 1, which is 1. And -5 over 1 is really just -5. So there's some proof of this. But if you're a person who likes to multiply straight across first, I can show that really quickly too. And then reduce after. So I'd get -45 over 9, and then I'd reduce that to -5. So however you do it, you get -5 as an answer. So there's -5, and then x minus 3 I don't touch because it's already in brackets. But now I get rid of my brackets. So I just multiply, I just distribute. So 9y plus 63 stays the same, equals -5x plus 15. All right. And then now I'm just going to try to do some work to get my y by itself. So subtract 63, subtract 63. I'm going to go up here, everybody. 9y equals -5x. Positive 15, subtract 63. So then that is, oh, I almost lost my spot there, -48. And then divide by 9, divide by 9, divide by 9. Y equals -5 over 9x minus, kind of an ugly number here. I could reduce that by dividing it by 3, so I'd get 16 over 3 if I reduced that. But you could leave it as 48 over 9 as well, so it's just kind of an ugly y-intercept. So there we go. Remember that to write something in slope point form, you need to determine the slope. Sometimes you're given it. If not, you can find it out like we just did. And then you need to choose a point. So the exact same style of question here, just a different presentation. Instead of giving you points, I've given you a picture. But we want to express this equation in slope point form. So same thing, we need to find the slope first. So the slope, I'm just thinking rise over run. Okay, so for rise or run, you want to pick two nice points or whole number points, meaning I want to choose something where the line goes through the corners of these squares because those are whole numbers. So I only have 3 to choose from here. And you pick any 2. So I'll choose this one and this one. And remember that you actually start on your leftmost point always. So I'm going to go down 2. So I go down 2, so that's negative 2 over 1, 2, 3. So negative 2 over 3 is my slope. And then I choose any point I wish from the line. So I have 3 choices, meaning I could present this slope point form 3 different ways because I can use, one way per point. Doesn't matter. So maybe we don't want this one to feel left out. We don't want this point to feel left out at all. So that would be 6 and negative 1, that point. So I'll choose that. I'm just going to call it, seeing it's the third point, I'll call it point C. 6 and negative 1. And then the third step, we actually put it in slope point. And we won't convert it or anything. We're just going to leave it in slope point. So y minus, I'll leave my open bracket, negative 2 over 3. X minus, I'll leave that open bracket. Again, you can skip that and go right to your final answer if you feel comfortable. So this would be negative 1, this is 6. So it would be y plus 1 equals negative 2 over 3, x minus 6. And you can see I kind of made that a square bracket that time. That's okay if you mess that up like I did, because it isn't a mess up, it's just I want to make sure my x minus 6 is in its own bracket. But there you go. So 3 distinct steps. Find the slope, find a point, put it in slope point form. Same thing here. You got to pick whole number points. So that's where the graph line goes through the corners of our grid here. So this time I have 2, 4, 6 different points, meaning I could have 6 different versions of slope point form, which again, as a teacher, that makes a lot of different things for me to correct, but they're all right. So whichever you want to work with. I'll pick this point and this point. Actually, I'll pick those 2 points, doesn't really matter. So step 1, I'm in red now, that's okay. We want to find that slope. So m equals rise over run, so 1, 2, I went up 2, and then over 1, so my slope is simply 2. Point-wise, you choose any of the points, and I'm going to choose this point just for a reason, because it's going to make my slope point form look kind of funny. So the point there is 0 and 1. So when I write it in slope point form, you're going to see it just looks a little bit different. And that's good to see that things can look different. So y minus, this is going to be a 2. X minus, and this is my x1, this is my y1. So y1 is 1, this is 0. So I end up getting y minus 1 equals 2, bracket x minus 0. You could write it, you could leave it like that if you wished. But it would also maybe look like this if you didn't want to write it like that. And then that would actually work out to this as well. So all of these would be valid. So that looks kind of funny, right? So again, slope point can have a lot of variation. So that's why some people don't like it. It's fine. Like it's actually really nice to work with when you have a picture, like in B here, because in this one, my intercept is a nice number. Sorry, everybody. You can tell I'm at school already doing this video. The bell just went there. But back to this. I had a nice intercept, so I could have put this in slope-intercept form really quickly, easy. And just as a reminder of that, that would have been y equals whatever my slope is, so it's 2x. And then my y-intercept is 1, so that would be the slope-intercept form, and that was really quick. But if it's not a whole number, if it's like an ugly fraction, then slope-intercept form isn't the nicest to work with, and that's where slope point form would come in, that you could just find some nice point on that line. So that's why we have a couple different versions, if you were wondering. Okay, now we want to graph this line. So remember, to graph a line, we need 2 points. So hopefully you kind of realize right away, we can find 1 point right away from this, from my presented equation. So I'm going to write it again. I hope you're not getting tired of that, but I'm writing it out in this open bracket form. And now for this thing to look like positive 3, I know that has to be negative 3 because that would be my sign change. And then for this to look like x minus 2, that means this has to be a positive 2 because, again, of my sign changes. So meaning my point would be 2 and negative 3. And you can definitely do that in your mind without writing it out, but seeing I'm writing a video or making a video, it'd look kind of weird if I just did everything in my head. The second, so this is my point. Step 1 was finding my point. The second thing we want to do is we want to know our slope, and a slope is really nice in slope point form or slope-intercept form. So that's just negative 3 over 4. Now, once you have slope and a point, we've gone over how to graph that before, but in case you forgot, you put your point down first. So 2 and negative 3. And slope can be seen as directions between points. So the slope will tell me how to get to the next point. And if there's a negative, I suggest associating the negative to the top number, so it'd be negative 3 over 4. But like I've shown in previous videos as well, you don't have to. But if you do associate to the top number, that kind of falls in line with the rise or fall over run, like the thing when we've been using rise over run. Anyway, it's telling me to go down 3, 1, 2, 3, and over 4, 1, 2, 3, 4. Whoa, it just barely fits on my my chart. And then now I can draw a line through it. Perfect. So there we go. It's graphed. That was pretty quick. Let's look at another one. Maybe this time we'll practice finding our point without writing it out. So if it looks like y minus 2, that means my y value must have been positive because it didn't change the negative sign. It'd have to be another negative to change that negative. And then for x plus 1, it means that must have been a negative 1. So it must have been x minus a negative 1 to make it look like x plus 1. Okay, my slope, it's stated clearly in that equation, just 2/3. So I got everything I need. We always use this as your starting point when you're graphing. All right, so there's my starting point. So negative 1, positive 2. And then my slope, it's telling me to go up 2, 1, 2, and then over 3, 1, 2, 3. And you need 2 points to draw a straight line, so those are 2 points. We could keep using slope, like you can see here, I can go up 1, 2, and then over 1, 2, 3, and there's my next point. But you only need to do, or you only need to highlight 2 of the points. So don't do extra work. Example 6. By the way, feel free to pause videos whenever you want. I'm sure you figured that out yourself, but this is kind of a longer video, I know, so pause it if you need to. Anyway, write an equation in slope point form for the line that passes through this given point here, 4 and 3, and is parallel to the line y equals negative half x plus 2. Well, we got to think back now. What characteristic will ensure that these lines are parallel? And if hopefully you remember that, that would mean their slopes have to be equal. So our slope for this new line, we'll say M2 for the second line, will have to be negative half because the slope in this given line is negative half. And then we're given this point here, A, 4 and 3, and now I have enough information to write the equation of this new line, and I know it's going to be parallel because it's got the exact same slope as that given one. So I can just go right into it now. Y minus 3 equals negative half x, or negative half bracket x minus 4. So that would be the equation of a line that is parallel to this given one. B, now we're at same idea, same point, same line, but now perpendicular. So how do I ensure these two lines are perpendicular? Sorry again, Bell. How do I ensure that these are perpendicular? Well, I have to make a negative reciprocal of the given slope. So the given slope is negative half, meaning this new one will be the reciprocal of 2 over 1. And we want it to be opposite signs. So seeing that one's negative, this is going to be positive. 2. And then the point we already know is 4 and 3. So again, I have everything I need to express this. So y minus 3 equals 2 bracket x minus 4. And that'll be the equation of a line that is perpendicular. to that given line. Final example, everyone, a problem. The sum of the angles in a polygon is a linear function of the number of sides of the polygon. The sum of the angles in a triangle is 180. The sum of the angles in a quadrilateral is 360. Okay, so this might sound confusing, like how are we going to be dealing with lines and things if we're dealing with angles? Well, we're just going to read a little bit further and hopefully it becomes clear. It wants us to write a linear equation. So that's meaning we could write it in slope-intercept form or slope point form, and there's even another one called general form that we're going to look at in the next video. Oh, sorry, I kind of got ahead of myself there. It says write a linear equation in slope point form. So there's three different types of forms, but we're going to choose slope point form to express the sum of the angles, S. So the sum of the angles, S, as a function of the number of angles, N. Okay, now the thing I want to highlight is this phrase here, as a function of. That is telling you what is the independent, what is the dependent. Whenever you see that phrase, that whatever was described before it is always your dependent or your y, and whatever comes after it is your x. So why do we want to know that? Well, now that I know what is the independent, what is the dependent, I can actually build points. And once I have points, then I can find a slope, and then I can pick one of those points and put it in slope point form. So, okay, I'm going to make these points. So it says number of sides. So if I look at, it says the sum of the angles in a triangle is 180. Well, triangle, I know how many sides that has, 3. And the sum of the angles is 180. So this is my x and this is my y, and I got that from over here. Okay? So it had a description that was trying to tell you what goes with what. But it's kind of code, right? Like if you didn't know that as a function of is code for, hey man, this is the independent dependent variables, then you would have no clue how to do this. But now you do. So now the other point, it's a quadrilateral. So now I have 2 points, meaning I can find the slope, and then I can write this in slope point form. So I'll do that. So my slope m equals, so now I'm going to call this one x1, y1, this one x2, y2. So 360 minus 180 over 4 minus 3 equals 180 over 1, or 180. Okay, second part, choose a point. It doesn't matter, but I'll choose the first point, 3 and 180. Third part, I can now put it in slope point form. Okay, so slope point, so it's going to be y minus 180 equals 180 again. I had to look twice there as well. X minus 3. All right, that's my slope point form. Now, that's all of A. B, use this equation to determine the sum of the angles in a dodecagon. Okay. So dodecagon, that means 12 sides. So I don't think I quite have enough room here, and I think I have one more slide. Yes, I do. So let me write, oh, I guess I don't need to. So my equation is y minus 180 equals 180, x minus 3. And we're saying the number of sides, determine the sum of the angles in a dodecagon. So I know the number of sides. And again, number of sides, that ended up being our x. So in this one, we're going to sub in x equals 12. So I'm simply going to do that. Y minus 180 equals 180. 12 minus 9. And then just work it out for whatever my y value equals. And y will be the sum of the angles in this 12-sided polygon. 180 times 3. 540. Add 180. 720. So as a point, it'd be 12 and 720. Now, if you think about that, that seems pretty low, doesn't it? So I know I could just edit this because there's a mistake, but I'm actually going to show you how you'd find your mistake. So let's see if you can find my mistake. Take some time and look at it. You can pause the video and look. I'm not gonna wait for 30 seconds on the video. You can pause and look. Right here. So look how basic a mistake that was. I just wrote a 3 as a 9. And you know what I did? This is what I'm bad for. I did the math in my head already. So 12 minus 3. So this should really be a 3. So that would equal 9, meaning this should have been the 9. So I answered my own question really quickly. So this stuff doesn't make sense, and this doesn't make sense. I know I could have re-edited this and just done it again to show that it's right, but I wanted to show you that it's so easy to make a mistake. Like, that wasn't even a math mistake. That was me just working too fast in my head. Okay, so I got to do this again. So y minus 180 equals 1,620. Then I add 180 to that. So y is going to equal, that would be 1,800. Meaning the answer would be that a 12-sided polygon, the sum of all the angles inside of it would equal to 1,800. And that is the correct answer. All right, so that was a lot of content. That was a half-hour video, so I'm sorry for that. Hopefully you took a couple breaks. Reminder, you can always watch it again. If things didn't make sense, go talk to your teacher or contact me. Have a great night, everybody.